Force is any interaction on an object that, if unopposed, will cause it to move. An example is gravity, which acts on objects to pull them towards the ground at a rate of 9.8 meters per second squared. Because gravity is constant across the Earth, scientists developed a standard for force called the Newton. A Newton is the amount of force required to accelerate an object with 1 kilogram of mass at a rate of 1 meter per second squared. So on Earth, gravity exerts 9.8 newtons on 1 kilogram of mass. If we reverse that, then a Newton equals about 102 grams of weight. The Newton is too large to be useful for calculations of force within the human body, so instead we use dynes, which are 1/100,000th of a Newton. The calculation of any force is determined by multiplying the mass of the object by its acceleration. The greater the mass a moving object has, or the faster it's moving, the greater the amount of force it exerts. Imagine we have a bowling ball and we allow it to roll downhill towards a stack of boxes. As it accelerates, it gains a little bit of force that it can exert against the boxes. Now, what if we increase the mass of the bowling ball? It still has about the same acceleration, but the increase in mass allows it to exert a much greater force against the boxes. So now let's go back to the original bowling ball and really increase the acceleration. By doing so, we give it a lot of force it can exert. So what does this mean for us? Well, if you've ever worked trauma, then you know that there is a big difference between a gunshot wound from a pistol and a gunshot wound from a rifle. Even though the rifle may have a smaller projectile, the massive increase in acceleration means that it can produce a tremendous amount of tissue damage due to the increased force it exerts.